All right, guys, sorry about that and the technology issues. Like I said, hopefully they'll be fixed this week, but it has been quite a day for me. So, yeah. Computer's not working. Computer totally crashed, so I was trying to teach from the iPad Pro. So now we'll try and record a lesson and see if this works. But hopefully it won't be too bad in terms of this is the second half of the lesson. The homework solutions for last night's homework that was due today is in the Schoology folder. And also, I will put these homework solutions in there as well. And then Friday is just going to be a mixed practice today of all of 7A and B. And then next Wednesday, we'll have like a quiz over those things. Not a test, just a quiz. And then we'll continue on to Unit 8. And then there'll be a big test over those 2 units. But anyway, if you want to find the probability of event either A or B occurring or both occurring, then you can think of this in the Venn diagram of the probability of being the union of these 2 things. All right, so the union of A and B together. All right, simply adding the probability of being in A to the probability of being in B will not count as the intersection twice, so you need to subtract one lot of the intersection. So basically, what that's saying is if you take the probability of A and the probability of B, actually, I think that's harder to see, and then you subtract their intersection, you'll have what's here and what's here, and that is their union. Okay, so you take all of A and you take all of B and subtract their intersection, and that will leave you with the union, because the overlap is the intersection. So the starred part is the union, the over part, this in here would be the intersection, but that's not what we're talking about. We're talking about the union. Okay, so for example, if you had the probability of A being 0.4, the probability of B being 0.3, and the union being 0.5, find the intersection. So all you do is you take that whole notion of A union B equals the probability of A plus the probability of B minus the intersection, and you literally plug in. So in this case, we have the union, and it equals the probability of B plus the probability of A plus the probability of B minus the intersection. Simplify all your like terms, and you get A intersect B is 0.2. So sometimes you're looking for the intersect, sometimes you're looking for the union, sometimes you can find probability of A or B, but very straightforward. Just remember, to find the union, you're taking the whole A, the whole B, subtracting their intersect, and it's what you have left. It's very much like a geometry problem. Okay, so that, I'm really not digging the pink highlighter. All right, so overall, we're looking at combined events, okay? So the next thing we're gonna look at is mutually exclusive events. And a mutually, let's just say it this way, 2 events are mutually exclusive if they cannot both happen at the same time. Okay, so the probability of 2 mutually exclusive events happening at the same time is 0%. They can't happen at the same time, so the probability of them happening at the same time is 0. All right, so that's exactly what this says here. If events A and B are mutually exclusive, then their intersection is 0, because they cannot happen at the same time, and their union would just be whatever the probability of A plus the probability of B is. All right, so you have, if you have 2 events, A and B, that are mutually exclusive, and the probability of A is 0.5 and the union is 0.8, find P of B. So as we said above, the probability of A union B is just probability of A plus probability of B. All right, and we know that their union is 0.8 and that A is 0.5, and we want the probability of B, so it is just 0.3. All right, so that is with mutual exclusivity. So two events are mutually exclusive if they can't happen at the same time. So there's no intersection, because literally you would have a Venn diagram with like A over here and B over here. So there's no intersection, and then their union would just be A plus B, which should make sense. Kind of looks like a cassette tape from the 80s, but we'll leave it at that. Anyway, conditional probability is our next term, and that means something very specific. If the probability of event A happening depends on a previous event, B, then the probability is said to be conditional. All right. So if the probability of event A happening depends on a previous event B, then the probability is said to be conditional. So this is written as P of A is conditional on B. All right. So the probability of A happening given that B has happened. So probability of A happening given B happened. Okay, it sounds confusing, but I think when we put an example to it, it'll make a little more sense. All right, so a pack of 52 cards, you know me and cards, contains 13 hearts. The first card taken from the pack without replacement is a heart. What is the probability that the second card will also be a heart? All right, so we are looking for the probability that the second card will be a heart depending on the first card being a heart. Well, if I've already taken the first card out and it's a heart, there's only 12 hearts left because there were 13 to begin with. And there are 52 cards in a deck, but I've already taken one out. So there's only 51 cards left, and that reduces to 4 out of 17. All right, so it makes common sense as well. I think the wording is almost more challenging, but if I've taken a card out that's a heart, so now there's only 12 hearts left, and I've taken a card out of the deck, so there's only 51, that's just my probability. It is what it is. It is what's left, okay? Hopefully that makes sense. All right, another example of conditional probability. The probability of a randomly chosen student studying French is 0.4. A student studying French and Spanish is 0.1. Find the probability of the student studying Spanish given that they study French. That sounds super confusing. I think I'm going to draw a Venn diagram because for me it helps figure out what we're trying to say. So we basically have the French students, all right? The only French goes in here, so no overlap. Probability of studying French and Spanish is 0.1. So this is Spanish out here. All right. So find the probability of a student studying Spanish given that they study French. All right. So that's P of studying Spanish given that they already study French. So that would have to be part of the intersect anyway. So it's just 0.1, the intersect, divided by the total, which is 0.2. All right, because the probability of them being in French and Spanish is 0.1 out of a total of 0.5. So whatever we have left is 0.2. All right, the last thing we have are independent events. All right, two events are independent if one doesn't affect the other. So in other words, P of A, B would just be P of A. All right. So basically what that means, so two events are independent if one doesn't affect the other. So in the last one, we were talking about something being dependent on the other one. So if events A and B are independent, then their intersection is just the probability of one times the probability of the other. All right. I thought there was something I wanted to say. Okay, I don't know what I was going to say. All right, so anyway, an example of that. The probability of a randomly chosen individual in a society being male is 0.52. All right, so we have male is 0.52. Probability of being Irish is 0.18. If these two characteristics are independent of one another, find the probability that you're male and Irish. All you do is multiply the probabilities together. Like, one does not depend on the other, so all I have to do is multiply those together, and I get 0.0936. Very straightforward, very easy. So that's 9.36%, just so you know. Often we're talking about probability. Probability is just written as a decimal, not the percentage. All right. That kind of sums up the lesson. Again, I'm sorry for the technological difficulties. We were going to go through this together, but maybe that'll be our warm up on Friday. Yeah, I think we'll do that on Friday together. All right. So I hope that makes sense. And sorry again, I know it's like frustrating and frazzling, and for me as well, it's been quite a hectic day. So yeah, I will see you guys soon. And thanks for the patience and understanding. Bye.